We have multiplication of polynomials. How we do this? We have to multiply every expression in the first parenthesis by every expression in the second parenthesis. So let me write this. We have x first times this whole expression in the second parenthesis. So times x squared plus xy plus y squared. And now we have negative y, we have to multiply by every expression in the second parenthesis. So let me copy this, x squared plus xy plus y squared. So this is equal. Now we have to use distributive law of multiplication. We have to first distribute x over each term in the polynomial, and next we have to distribute negative y over each term in the polynomial. So we have x times x squared. Next we have positive and positive. When we don't have sign, it's always positive, so we have positive x times xy, and positive times positive, so it will be positive x times y squared. Now we have negative, positive, so it will be negative y times x squared, negative times positive, so it will be negative, and we have y times xy, negative times positive will be negative y times y squared. So this is equal. When we have multiplication, the same base, we copy the base and we add exponents. When we don't have exponents, it's always invisible 1, so 1 plus 2 is 3. Next we have plus x times x is x squared, and y we have to rewrite, plus xy square, and next we have y times x square, so negative sign we have to rewrite, and we write in the alphabetic order variables, so it will be x square y minus, we have to copy, and we have y times y is y square, and we have x again, we will put in the alphabetic order, so it will be x times y square. How I get y square? Again, let me remind you, when we don't have exponents, we have invisible 1. When we have the same base and we have multiplication, we copy the base and we add exponents. 1 plus 1 is 2. And negative sign, the same for y we have to use, the same base, we have to copy the base and we add exponent. When we don't have exponent, it's always invisible 1. So 1 plus 2 is 3. So this is equal. Now we have to combine the like terms. We have x squared y and negative x squared y, so we can cancel out this whole expression, and we have xy squared and negative xy squared, so we can cancel out this term also. This gives me 0 because it's like invisible 1, coefficient is invisible 1, so we just have to add the coefficients 1 plus negative 1 is 0. So this whole expression, doesn't matter what kind of variable we have after 1, when we have the same xy squared and xy squared, the like terms, we only check the coefficients. 1 minus 1 give me 0. That's why I cancel out these two terms, the same with the x squared y. We have invisible 1. So 1 minus 1 give me 0, and it doesn't matter what is after 1. We have the same term, x squared y, that's why we check only the coefficients. 1 minus 1 give me 0. That's why I cancel out these two terms. And now we can rewrite whatever left, so we have x cubed minus y cube. This is my solution. This is formula for difference of two perfect cubes.